Everyone, to our 35th episode in the Space Shooter DevVenture. So at the end of the last live stream, we almost had things working, right? And I wanted to just take a moment to fix any of the remaining bugs, although I found the bug just after the live stream, so I fixed it. So I apologize for depriving you of seeing that solution, but I'll show you the result. So here we go. If I run the test scene, then I'll show you that it actually works now, right? So in the beginning, it doesn't go anywhere. Okay, it should have, based on our previous content, maybe not content, but like in the previous setup, it used to go on its own, right? But now it's waiting for input. So now all I have to do is press one of the num keys, right? So either num key 1 through 8 or num key 0, and num key 0 will give us a random waypoint, whereas the numbers 1 through 9 will choose the specific numbered waypoint, right? So if I press 9, you should see it go straight for 9. Oh, yeah, okay. I pressed 8 and 9 at the same time by mistake. Okay, there it goes towards 8. Watch this. Boom. It's ready. It's ready and waiting, okay? And now I need to give it another one. So let's say go towards, this time I'll press 9, actually, and deliberately I'll press 9. See how it goes in that arc towards 9? The angle is right. The approach is right. Boom. And there it hits 9. And you can see at the bottom there, in the... Oh, no, you can't because my face is in the way. Let me just move my face out of the way so you can see better. There we go. So if I press resume, you should see now the feedback. And if I press another waypoint, something like waypoint 1, there it goes. And you should see now in the output window at the bottom there, enemy ship 0 assigned to seek pattern waypoint 0. And now enemy ship 0 assigned to seek pattern waypoint 0, and then seek behavior complete, target reached. So there we go. Everything's working as it should. The only thing that isn't doing what it used to is that on reaching a waypoint, it's not being assigned a new one. And at the start of the scene, it's not going to a random waypoint. But that's okay. We don't need that behavior. We just need to test that seek is working as it should, right? And now we can advance this test level so that it's no longer only for seek. We can adjust it so that it's for every behavior, right? So for seek and for chase and for flee and for flying in formation and for shooting at a target and all kinds of things. And now we are getting closer to having the behavior I mentioned a few live streams ago. Hi, welcome back to the live stream. So in a few live streams ago, I mentioned we were trying to make the steering behaviors, right? And if I go towards the bottom here, you should see wait. Understanding steering behaviors. Here we go. Here we go. So we were busy with these. I can move my face back to the corner now. Right. So you can see there's seek, which we implemented, and then there's others like flee and arrival, wander, and then pursuit and evade, movement manager, collision avoidance, path following, following the leader, queuing, right? And the one that we are building towards is this, the movement manager, right? And that's what the NPC behavior manager is all about. It's supposed to it's supposed to manage behaviors, not just movements, but behaviors in general, right? And the enemy ship controller is also meant to control enemy ships, right? But then we've also got behaviors like this one, which is Q, which is useful for our mining vessels, right? When they are returning, I mentioned this before, but when they return towards the capital ship to offload their cargo, if they all arrive at the same time, you need to kind of manage how they do that, and so you'd have to make a queue, right? And so they'd have to queue and line up by the collection point, the offloading station, whatever you might call it, right? And then following the leader, this one would be more like the pirates, because they fly and attack in packs, right? So there'd be a leader, and there would be some pirates flying in formation around the leader, right? Following the leader, flying in formation and keeping things going. And then you've got patterns, attack patterns, and all of those things. So all of these would constitute a pattern, or actually, no, they wouldn't constitute a pattern. They would be behaviors that build up into patterns, right? And the NPC behavior manager would choose how to fulfill a pattern with these kinds of behaviors, and the enemy ship controller will call out a pattern. It would say, okay, attack the defender, or annihilate the defenders, right? That's a pattern. And then the enemy, the NPC behavior managers would say, okay, well, in order to defeat the defenders, we need to first know where they are, right? And so we'll have to start doing wander and find out where they are, right? And then once we know where they are, then we need to seek them out, because seek isn't actually seek. It's not going to look for something. Seek actually means home in on something, like go towards a point. Choose a location and move towards it. That's what seek is. Whereas wander is just move in, just move around, explore, do what you want, right? And flee is the opposite of seek, because you are moving away from the target instead of towards it. And then pursuit and evade, this one is more like if you've got the... I'm just trying to think of the way to explain this. If the mining vessel is already returning towards the capital ship with a full cargo, or with enough cargo to make a meaningful deposit into the storage facility, and the pirates have identified this, they will start to pursue the mining vessel. And at the same time, the mining vessel will need to evade the pirate, right? And so that's where pursuit and evade comes in. And then all of these are governed by the manager, the movement manager. So we're not doing exactly what they are saying in these tutorials, but we are using these tutorials as a scaffold around which we build our own systems. Okay. So at the so the next step now, let me just see now. So this is what we were doing. So I mentioned that I fixed it, and I set the inertia factor. So let me just show you what that does, because that's important. So if I go to the pirate enemy, you'll see there's this variable called inertia, right? And the inertia is used to govern how fast the enemy ship can change direction, right? So if I change this, and this is our own variable, by the way. So we created this variable as part of type enemy ship. The default value is 0.05, and that is way too small. And let me show you what I mean by way too small. So if I go to testing seek behavior and I run this scene, watch what happens when I choose one of the... Okay, let's start off by it's facing 2. So let's say, okay, go towards waypoint 2. And off it goes, right? That's fine. It's going in a straight line. But what happens when I tell it to go to waypoint 4, which is the opposite direction, 180 degrees away, right? Look at this turning circle. Look how slowly it's turning. I mean, it's turning, it's getting there. But what happens if waypoint 4 was closer to 2? You know what I mean? So that's really, really, really difficult to get to wherever you need to go. You need to do some seriously wide turning circles, and there might not be enough room and all of that kind of stuff. So this is for like, if you really wanted to emphasize that something is going like really fast through space, then this is what that would do, right? It would communicate, oh, it's going so super fast that the speed is making it hard to turn. And maybe you could do that. You could make, and you see it's completely missed waypoint 4 now. So if you wanted to, you could make the inertia factor less as it gets faster, and more as it gets slower, so that it's more maneuverable when it slows down. But for now, I think we'll just make it a high value, like 0.75, because 1, let me just show you what 1 looks like. If I go to testing seek behavior and I run it again, look what 1 does. If I go straight for waypoint 4, it turns almost on the spot. You see that? And so that's just a little bit too sharp. I want it to be a little bit more wide. I want it to be a little wider in its turning circle. So 0.75. Here we go. If I choose waypoint 4 now, you'll see it still turns quite sharply, but not nearly as sharply as with 1. And maybe if I made it 0.5, it would be a bit better. Let's try that. 0.5. Save that and run this. Let's try this now. It shouldn't turn on the spot. It should be moving at all times as it's turning, right? So let's try waypoint 4. That's better. No, it's not. .75 is fine. Okay. So we've done that. And now we can move on to other things. What was the next thing we wanted to do? So now we have the strategic layer, the tactical layer, and the operational layers. And the next step is, we have some steps to follow here. So we can add more behaviors, something like combat, mining, evasion, patrolling, or we can do role-specific AI, right? Or we can do behavior parameters. And then it made a comment about using inertia as a tuning variable for maneuverability. Excuse me. So the next thing we can do is to add more behaviors, right? So let's do the shoot behavior, because I want to make sure that the pirate enemy can actually shoot, because a pirate should be able to attack, right? That's one of the 2 behaviors it needs to do, is to chase after its target and then shoot at it. And then after that, it needs to flee again. So there's a pattern, right? So I'm not sure what to name that pattern yet, but the pirate's attack pattern should be seek towards a target, right? So go straight for the target and then shoot at it a few times. And then once you reach a certain distance, start evading again. Like swoop in, start shooting, and then swoop out again, and do that repeatedly. Like, just trying to get my finger in the camera's view. So it's like swoop. So let's say the microphone is the target. So like this, and then fire, and then zoom away, and then come back and do the same thing. Fire, and then swoop away. So we wanted to do that. So in order to get that, we need to have all the behaviors ready to build up that pattern. And the 2 behaviors we're missing is shoot and flee. We've got seek, we need shoot and flee, and then we've got the 3 to make up that pattern. So let's do those. Where is in my scripts? I need to find the logic for shoot. Here we go. Shoot. And if I go to the shoot script, it's empty. If I go to the player, it's not empty. I need to go into the pirate enemy script, copy everything, and then go back to DeepSeek and ask it but to help me. Ask it to help with extracting all the shoot logic into a shoot script, right? So here is the enemy ship behavior .gd file. So we paste it there. All right. And here is the shoot.gd file. As you can see, the shoot.gd file is still empty. I want to extract the logic about shooting from the enemy ship behavior script and put it into the shoot.gd file so we can have a shoot behavior node. And then also here is the scene tree of the pirate enemy scene. Pirate enemy. So we've got the enemy ship root. And that's of type character body 3D. And then we've got a mesh main body, and that's a mesh instance 3D. Then we've got a collision main body, that's a collision body 3D. Then we've got wing thruster light underscore. And then we'll copy that because we're going to need to use that a few times. Out left, and then out right, and then in left and in right. Okay, and then these are OmniLight 3D. We'll copy that and then paste it here. Cool. And then we've got a tail thruster light, which is also an OmniLight 3D. I wish there was a faster way to do this. If anybody knows a faster way to do this in Godot Engine, please do let me know. That would help a lot. But unfortunately, this is the fastest way I can do it. Health bar 3D, health, gun dash pirate, and enemy ship number. That's a label 3D. And then finally the NPC behavior manager. Okay. Health bar 3D is of type health bar 3D dot scene. And then health is health dot scene. Gun pirate is a specific class, isn't it? Nope. Also gun NPC gun dash NPC dot scene. So the reason I'm doing this is I'm giving DeepSeek as much context as possible in order to make sure that when it does give help, that it's as relevant as possible and as helpful as possible. Okay, so that should be that. We've got the enemy ship as the class. We've got the two scripts, the shoot and the enemy ship controller, or enemy ship behavior rather. So now we can say, please help me get this sorted. Perfect. Let's extract the shooting logic from enemy ship behavior and create a proper shoot behavior. This will give you a modular combat system that can be assigned to ships via the AI behavior manager. Step 1, create the shoot behavior. Here's the complete shoot file. Sorry about that. I've got some eyelash or something in my eye that's irritating me. Okay. So here's the complete shoot file. So it extends node. It has a class name, type behavior shoot, which is exactly what we want. The class name should always have the type prefix. And that was one of the stipulations I gave DeepSeek for this project, is that any class that we create needs to have this type prefix, so that when we read the script, we know immediately, oh, we are using a self-defined class, right? Or a manually defined class, rather. So that's type behavior shoot. We gave it a signal, behavior completed. Excuse me. And that is going to fire off once the shoot behavior is done, right? So once it fires a projectile, it says, hey, I finished firing a projectile. And then, it's ready to be called again. So the key points is the enemy ship ID, so who did the behavior type, what was completed, right? So who did the behavior, what behavior was it, and what was the status of the behavior when it was complete, and is there any relevant data that you can share? Okay, and this is a nice pattern to have, and you can kind of tell with all of these signals that we've defined before, they have the same kind of pattern, right? So who did the behavior, what behavior was it, what status was the the completion, so did it pass, did it fail, was it interrupted, what was the status, and is there any other data you can share? So so not in this case, but in another case, like let's say the mining vessel destroys an asteroid, you would send a signal that the asteroid was defeated. So who defeated it? The mining vessel. Which mining vessel? That one with the ID. And then what is the behavior type? Well, he destroyed a mining vessel. No, he destroyed an asteroid, my mistake. And what's the status? It was a success. He actually broke the asteroid down. And any other data? Yes, he collected so much resources of so many types, right? So iron, this much. Steel, this much. Carbon, that much, and so on. But for shooting, any additional data might be just trying to think. It's fine. We'll get there. Let's not waste too much time thinking about things like that. Okay, so then the variable enemy ship is a type enemy ship. The target node is node 3D. Who is it shooting at? And then parameters, dictionary, is active, false. By default, it's off. The shot cooldown is a timer. Can shoot, boolean true. Plasma bolt scene, packed scene, that's the scene of the plasma bolt. It's got a function for activate. When it's activated, who's activating it? And then what behavior parameters should it receive? All right, so the enemy ship, getParent as enemy type. And so we're getting the parent twice, remember, because this behavior is a child of the NPC behavior manager. And the NPC behavior manager is a child of the enemy ship. And so we need to get the parent twice. And we need to make sure that it is actually of type enemy ship. And if it's not of type enemy ship, or if it's not initialized, so if it's null or if it's not a type enemy ship, then we push an error that the type behavior shoot could not find the enemy ship that it's attached to. Behavior completed, emit, ship ID, shoot, failed, and the reason, no enemy ship. Okay? And then at the end of that, we return because there's nothing left to do. It's already failed. But if it passes this, obviously that it is both not null, so it is fully initialized, and it is of type enemy ship, then we continue and we add the behavior parameters to the parameters dictionary, and we set is active to true. Then once that's done, we call initialize shooting, which is a function down here. We'll get to that. But for now, we'll just carry on. After initialize shooting is done, then it checks if parameters.has a target node path. Then the target node is enemy ship.getNode parameters target node path. I'm not sure why it needs to do this though. Extract the target from parameters. Does it need a target? I suppose it does. Yeah. Because if you think about it, it needs to know the location of its target. And for more advanced shooting, you think about something like, if I were to show you as a drawing, in this situation, you've got the enemy ship. Excuse me, just getting my pen tablet out. And the pen. Okay, so if we have this kind of setup over here, we will make the enemy ship the red pirate, so we've got a red pirate over here, and we've got a mining vessel over here. So not only is the mining vessel a different color, but it'll also be a different shape, okay? And we'll make that a rectangle with the long axis pointing in the direction of the mining vessel. something like this. And then we can maybe add an arrow on the end to show which direction it's going in. Okay. Now, if the mining vessel is traveling with a velocity of, I don't know, 25, arbitrary number, I know, but what can you say, right? It's moving at 25 in this direction. Then we want the projectile of the enemy ship, we'll make that like a magenta color. We don't want to shoot directly towards the enemy, towards the mining vessel, because maybe the projectile that it fires only has a velocity of 50, let's say. Okay, so then we want to shoot in an angle like this, because the velocity is 50. Okay, and so it moves twice as fast as the enemy. And so at some point, it's going to need to intercept that enemy line. And so you kind of need to know the position of the target, and you need to know the velocity of the target. And once you know those two things, you know where to fire. And again, it's not that simple, because you also need to know how maneuverable the target is, and if it's likely to swerve or move out of the way, or any of those kind of things. But that we can build on that, right? So that's just complexity that we can add on later. For now, we just need the basics. So assume the target is stationary, get its location, and fire. And then later on, we can start doing other things like intercept trajectories and all of that kind of stuff. Okay, so that's why it's getting the target's node path and all of that stuff. Else, if the target has a target position, then currently we're not doing anything, because we haven't actually specified to DeepSeek what it should do in that case yet, but that's okay, we'll get there. Once all that's done, print shoot behavior activated for ship with the ship ID. And initializing shooting components. So initializing shooting. So remember, we called initialize shooting over here, and this is the details of that function. Okay, so if not shot cooldown, because shot cooldown is a there was a variable called can shoot, and I think it knows that because it saw through my code, right? So I think it's just it's fine. I think this is just a more direct way of getting whether the shot cooldown, which is a timer. So in Godot engine, you've got this thing called the timer. So let me just go over to the gun scene, and you can see what I'm talking about. So in the components, general components, NPC components, here we go, gun NPC. So in the gun NPC, you can see here, there's a timer shot cooldown, right? And then the gun main, which is a marker 3D, and then the root node, the node 3D, okay? So the timer has this shot cooldown, which is the wait time. And if you go into the signals, there's a timer.timeout, and so on. So I think it's trying to get this timer shot cooldown to gauge whether that timer shot cooldown is ready or not. Okay. We can fine tune this once we actually put it into Godot engine and see where the errors come out. Because again, DeepSeek isn't fully aware of all of my scenes and all of my nodes and how the things are named and everything. So we'll just take everything it says with a grain of salt or a pinch of salt, whatever the saying is, and we'll go forward from there. Okay. So the shot cooldown has a new timer. We give it a new timer, and we set the wait time to 1 second. Do we have to create a new timer every single time? No, I don't think this is the best way to do it. But okay, fine. We'll just follow the logic for now, and then we can question DeepSeek's approach afterwards. So once the wait time is set and the shot cooldown set to 1 shot is true, the shot cooldown.timeout.connect on shot cooldown timeout, add child shot cooldown. Okay, so here's the thing. Like I said, DeepSeek isn't fully aware of all my scenes, right? And I gave it the context of the enemy ship, the enemy pirate, the whole scene of the enemy pirate, right? But I didn't give it the context of the gun-NPC scene. And so I think that is where it gets the idea of, oh, it doesn't, he doesn't have a shot cooldown or a timer or anything, when I actually do. So I need to mention that. I need to give DeepSeek the context of the gun scene so that it knows there is actually a timer, and I should probably get that node from that scene and use that one, because that makes more sense, right? So if not plasma bolt scene, then set plasma bolt scene with a preload of the plasma bolt itself. Okay, and deactivate. So once everything's done, it needs to set active to false and send a message into the console to let us know that the behavior is deactivated. In the process function, if it's not active, or if the enemy ship is not initialized, or if it cannot shoot, just leave the process function. And then if target node and has line of sight. So has line of sight is another function which is defined over here. We'll get to that. So if it has line of sight and there's a target node that isn't null, right, then shoot at the target. And else if parameters.has target, then target position. If it has the target position, then shoot at that position with parameters at target position. Remember, parameters is a dictionary, and we access dictionaries with keys, right? So the key is this, the value would be the actual target position, right? So the actual vector 3 with the target position. And here we go in the function has line of sight. It's a Boolean, or rather it returns a Boolean. So if the target node is not defined, then return false. Otherwise, continue and say we've got a space state, which is the enemy ship.getWorld3D.direct space state. I've never actually seen this before. That's really interesting. Oh, it's doing a raycast. I've never actually worked with raycasts either. I normally just fire projectiles directly. So variable query physics ray query parameters 3d.create enemy ship.global position from the enemy ship position to the target node position, right? So draw a line between these two things, and then query.exclude any enemy ships. Well, not any enemy ships, the enemy ship. So if this raycast happens to collide with the shooter, the pirate ship, ignore that, because maybe the gun is embedded in the ship and the raycast is trying to get out of the enemy ship before it actually shoots. In that case, just ignore that and carry on, right? It doesn't ignore other enemy ships, just the one that's firing, which is reasonable. We can assume the pirates would install their guns so that they don't shoot themselves, okay? And then variable the result is assigned the space state.intersect ray query. And again, we created query to give us a value, right? So does it does it intersect? And that's the query, which is just a raycast. And then return result dot is empty, which is no obstacles. So it's not actually shooting things. It's just checking from me to the target. Is anything in the way, right? Is there an asteroid? Is there an ally? Is there whatever, right? And then it's going to return a Boolean based on that. And then if we move back up here towards the process function, if that is true, so if there's nothing in the way between the enemy ship and its target, at that time it's going to call shoot at target. Okay, and shoot at target is down here. So if the target itself is not defined, then just get out of the function, call return. Otherwise, we determine the direction by saying the target node's position minus the enemy ship's position dot normalized. And remember what normalized does? It just creates a unit vector. So a unit vector, like I think I've explained this before, but I'll do it again. A unit vector is just a vector of distance 1, right? So if you've got two vectors, let's just use green and blue to differentiate from this one. So if I've got a vector like this, okay, we'll call that vector sub 1. And I've got another vector here like this, and I say that one is vector sub 2. You can see that these two vectors do not have the same length. Okay, and let's say I wanted to do a distance between them. I would have to say move this one up here, right? So draw a parallel line, something with, let's go with white for now, just so it's clearer to see. So we'll draw a dashed line up like this. And then we take vector 2 and we move it up here like so until it coincides with that one. So now we've moved this vector up. Okay, so this is still vector 2. And now we draw a third vector, which will be a cyan vector because it's between green and blue. And what we do now is we draw a line like this. It's not straight, but what can you do? And that will be vector 3. Okay, now as you can see, vector 3 is actually longer than the other two. Now a unit vector takes away all of these magnitudes and it just leaves direction. And you want to see what is the direction that we need to go in between these two vectors. It's vector 3, right? But it's vector 3 dot normalized. And so what that does is it just chops the distance down to 1. Excuse me. But it keeps the direction intact. And so what that looks like is, if I go with like orange, it would just be a unit vector of length 1. And so that would be vector u3. Okay, I hope that makes sense to you guys. So that's why we're calling the normalized. Okay, so shoot at target, we're getting the normalized vector between the difference of these two things' positions. And then fire a plasma bolt with direction. And then fire plasma bolt has the, all the definitions and stuff down here. We can deal with that in a moment. For now, though, that was shoot at target. And then shoot at a specific position as well. So remember, this one is more for like doing that interception shots, right? So you know that the enemy or that your target is moving in a certain direction, but you don't want to shoot at their position. You want to shoot at a future position that you know that they're going towards to intercept them, that you have a better chance of actually hitting them. Then this is what that does. Shoot at position, right? It just takes a specific position, whatever that position is, as a vector 3, and calculates the direction towards that as a normalized vector, and then fires a plasma bolt with that direction instead, right? And then here we go, plasma bolt, firing the plasma bolt. Again, just making sure everything's initialized and that the ship can shoot. Then you've got the gun node, get node or null, gun pirate, spawn position, enemy ship.global position, rotation. So getting the position and the rotation of the enemy ship, and then again getting the position and the rotation of the gun itself, and then it's creating a plasma bolt by instantiating the scene, then adds that to the game scene, sets the global position and rotation, and then uses look at to orient the plasma bolt to face the target that it's shooting in. And then if the plasma bolt has a method set speed, then it sets the speed, and if it has a method set the color, it sets the color. And then can shoot, we set that to false, and shot cooldown.start. Because it's already shot, it can't shoot anymore until shot cooldown is done. Okay, and then on shot cooldown timeout, set can shoot back to true. Okay, so once the timer is done, we set the shot cooldown, we set it back to can shoot back to true, and then we can shoot again, and then that repeats every time. And then exit 3, if shot cooldown.q free. Okay, seems good. And then step 2, updating the enemy ship behavior. Remove all the commented shooting code and clean it up. And then step 3, update NPC behavior manager to support the shooting behavior. And step 4, scene setup and a usage example. This gives you a modular shooting system that works with your AI behavior manager. The ship will automatically track targets and fire when it has a line of sight. All right. So I'm just going to give it one correction and then see if it makes any changes. Hopefully it does. So I think you misunderstand something. No, I didn't give you the context of the gun-npc.scene file. There is already a timer-shot cooldown. Yes, cooldown node in the gun pirate, the gun npc .scene. So there is no need to create a new timer. We can simply use the existing one. Here is the context I should have given you before. Okay, so we've got gun pirate, which is of type node 3D, and then we've got the gun main, which is a marker 3D, and we've got timer shot cooldown, which is a timer node. And then this scene has a script attached to it called behavior gun npc.gd. Please use this to adjust your current implementation if required. Perfect. Thanks for sharing the existing gun system. This is much better. We can leverage the existing gun functionality rather than recreating it. Let's update the shoot.gd behavior to work with your existing gun system. Okay, so now rather than going through all of this again, we'll just assume everything is fine. And at the end of the live stream, I'll just go through it in my own time and confirm that. All right? We'll just let DeepSeek finish writing. So now you can use the shoot behavior in various ways. First, continuous shooting at the player, and then shoot at a specific position, like a turret, or a single shot, and then call complete behavior. The key benefits is that it leverages an existing system. It's flexible, it has aim assistance, line of sight, and it's configurable. The behavior will now work seamlessly with your existing gun pirate system and its built-in cooldown timer. Okay, so that's cool. And I just wanted to see how it actually works with the gun pirate. Enemy ship, gun system, target node, parameters, is active, continuous shooting. Get the parents, get the parent, that's the root node. The gun system is enemy ship.get node or null gun pirate. Yeah. Okay. Okay, that seems fine. So let's go to the shoot scene and add all of this into the shoot.gd behavior. Copy and paste. So let's bring this into view so you can see what I'm doing. Just paste all of that in, save that scene, and then if we go into the NPC behavior manager, we need to add our shoot behavior to that. So general behaviors, here it is, shoot.scene. Just rename the scene to have an uppercase S. And there we go. Okay, now I need to go back up and check for the preload of the plasma bolt. Let's see here, control find plasma bolt. No. This is the NPC behavior manager. We need to be here. Okay, here we go. At the top, plasma bolt. We'll find it. It doesn't have anything. Okay, so then we need to look at the shoot. Trigger a shot. Yeah, gun system on shot trigger. Gun system on shot trigger. Here we go, on shot trigger. So this needs to have the right plasma vault, and there we go, the unique ID. So we don't need to change the code here because it's already got the location of the gun node. I mean the plasma vault. And this is actually the better way to do it in Godot engine. It already has a unique ID, and so you don't need to worry about where in your file system you stored that scene. You just paste in the unique ID and it should work, right? Which is so much better. General components, the plasma vault. You can see there C85 LOH blah blah blah, and there it is, C85 LOH blah blah blah. Same thing. Okay, so that seems fine. And let me just check with DeepSeek. If I press the shoot uppercase S, the shoot button, will the enemy ship shoot? This behavior is in the what's this called? Behavior gun NPC. Behavior gun npc.gd file. And I want to make sure that everything goes through the, well, no, let's not say that. This creates a conflict between your AI system and input handling. The AI system should control when enemy ships shoot via behavior patterns. The input system currently makes all guns, including enemy guns, shoot when the player presses shoot. The recommended fix: you have two options: remove the input from enemy guns, the recommended path, or you can add owner check. Only allow shooting if this is a player controlled gun. Why option A is better? Clear separation, control by AI only, no conflicts, and there's more performance. And after making this change, the shooting behavior will work as intended. The player presses shoot and the player ship shoots. AI assigns shoot pattern, enemy ship shoots. No cross-contamination between input systems. This keeps your architecture clean and ensures the AI system has full control over the enemy behavior. Okay, so I'm just going to go back here and test in the testing seek behavior if it does actually shoot when I press the shoot button. So if I press the shoot button, it tries to shoot, but it fails because of some error. Now let's see what that error is. Invalid access to property or key ID on a base object of type node3d behavior gun npc.gd. I'm not sure what exactly it's actually trying to say. Why is this a problem? If gun parent is not null, set bolt shooter ID to be the gun parent's ID. But you can't do that. Why not? gunparent.id. What is gunparent? Main gun. Get parent. And the pirate enemy should have an ID. There it is. Strange. Anyway, we've run out of time, and this is a error that shouldn't even be happening. I don't want the pirate to fire when I left click like the player does in any case. So we can ignore that for now. Okay, just pretend that never happened. Sorry for taking up so much time about that. But yeah, so let's end over here. So I'll make a shout out, as I always do, to Cubes, our junior DevVenturer. Thank you so much for your support. And to everybody else, thank you so much for